Hi, I'm Shreyank, here to present CLASTER, Clustering with Reinforcement Learning for Zero-Shot Action Recognition, a joint work with the University of Edinburgh and Meta AI. Unlike in supervised learning, where we have well-defined annotated data for training and the same classes available at test time, in zero-shot learning, the test classes are completely disjoint from the training classes. In the zero-shot action recognition paradigm, instances of new target classes are recognized without any training data. Typically, at train time, the visual features and semantic features are trained with a similarity loss using a matching module in a latent space. At test time, a nearest neighbor search is done in the same latent space to find the unseen class. It has been seen that zero-shot learning models tend to overfit to the seen classes available at train time. Thus, we need a representation that can avoid overfitting. In CLASTER, we propose a representation for zero-shot action recognition based on three main ideas. First, we turn to clustering and use the centroids of the clusters to represent a video. We argue that centroids are more robust to outliers and thus help regularize the representation, avoiding overfitting to the space of seen classes. The left part of the figure shows that the gap between the training and validation accuracy is smaller when using clustering in seen classes. As a result, the learned representation is more general, which significantly improves accuracy in unseen classes, as can be seen on the right side of the figure. This can be verified through experiments as seen in the table. A simple k-means clustering improves performance. The standard practice at training time is to use a visual representation and learn a mapping to the semantic representation. This can be done either in the visual space, semantic space, or in a latent space. Our representation is a combination of a visual and a semantic representation, which we show yields a better overall representation. This is not surprising since both visual and semantic information can complement each other. We verify this experimentally with different methods of combination of visual and semantic representations. We see that concatenation gives us the best results and we use that. Third, we use the signal from classification as direct supervision for clustering by using reinforcement learning. We observe that using reinforcement learning is better than using alternative optimization methods. We also do a qualitative analysis of the clustering. We visualize the clusters using TSNE features. We observe that after the RL optimization, the clustering becomes cleaner. Now, let us look at the overall architecture of CLASTER. At train time, we map the semantic embedding to the space of visual features and concatenate both to obtain a visual semantic representation. We cluster these visual semantic representations with k-means to obtain initial cluster centroids. Each video is represented as the sum of the visual semantic representation and the centroid clusters, weighted by their distance. This is used as input for classification. Based on the classification result, we send a reward to optimize the cluster centroids using reinforce. At test time, we first perform classification on the seen classes and then do a nearest neighbor search to predict the unseen class using rectified semantic embeddings. Here, we look at the zero-shot learning results on the HMDB dataset. We see consistent improvements in comparison to the state-of-the-art using random splits, as well as the stricter TrueZ splits that avoids overlap of unseen classes with the pre-trained model. In conclusion, we propose a novel representation called CLASTER for zero-shot action recognition. This is based on three main ideas. We use clustering and centroids of clusters to aid the representation. The clustering helps regularizing and avoids overfitting to the seen classes. Next, we use a joint visual semantic representation that helps improve the overall representation. Finally, the clusters are optimized using reinforcement learning, and the reinforcement learning yields better, cleaner clusters. The overall cluster representation helps us obtain state-of-the-art in zero-shot learning and generalized zero-shot learning for action recognition.